calculating slope. We have two ways to calculate slope depending on two different situations. Situation one is you have a picture. If you have a picture and a graph, what do we use? Rise over run. Perfect, right? We can count it out. If you have just 2 points given to you, what do we use? The slope formula, right? The y2 minus y1 divided by x2 minus x1. That's how you calculate slope. We need that to be able to do what we actually built up to. The next thing we learned was parallel versus perpendicular. Parallel meant two things had same slope, right? They run like this, same slope. I don't know why I want to go on the side. The same slope. Perpendicular meant opposite slope, so they cross each other, right? They make a 90 degree. That meant they had negative reciprocal slope. We did a little bit of that yesterday. Then we got into creating equations, and we created equations 3 different ways. We had slope-intercept form. Slope-intercept form looks like this guy. You can create slope-intercept form when you have your slope and your intercept. That's why they came up with a really original name called slope-intercept form. The second way you can create equations is with slope-point form. Slope-point form would be this guy right here. That's good for if you have a slope and then just any point. Okay? You could even use the y-intercept and do slope-point form and it would still work. But this is just slope with any point and that formula would work. The third way we have is general form. Remember that we don't create general form. General form really doesn't tell us much. Right? It's just kind of nice and neat and it looks good. We always create in one of these two and then turn it into general form. Awesome. So now what we're going to do is we're going to take equations and we're going to graph them. And we're going to graph them by hand. We've graphed in the past using our calculators, and we've done a little bit by hand, but only with slope y-intercept. Now we're going to look at other forms and graphing them by hand. So if you look down here, we should have 3 examples. 3 examples. Of all 3 different types of equations. So if you look at your first equation, this thing is slope y-intercept form. Right? This thing is y equals mx plus b. I know it's slope-intercept form because y is by itself. If I wanted to graph in slope y-intercept form, the first step to graph in my hand is to have a starting point. You need somewhere to kick things off. Our starting point is our b value. In this case, positive 4. That's telling me my y-intercept is telling me where to start, right here. Then I need like a map to get to my next point. Your map or way of getting to your next point is your m value. So if you look up here, m value tells you how to get to your next spot. The reason that tells me how to get to my next spot is that's my slope. Slope is rise over run. In this case, our slope is only 2. Every slope is a fraction. It just might not always look like a fraction. If I wanted to turn that into a fraction, it would actually be 2 divided by 1. Whoa. That means I rise 2, I run 1. And that would take me to my next spot on the graph. So in our case, I go to my starting point at 4, I rise 2, I go to the right 1, that's my next spot. And I can keep doing that. Rise 2 over 1. Rise 2 over 1. Rise 2 over 1. And what I'm doing is I'm creating lines that I could then connect, dots that I could then connect to create my linear equation. For you guys, if you ever have to draw something, which you won't have to draw in your unit test, but if you ever do have to draw, take a flat edge, okay, and just make it nice and easy for you. A good flat edge is the back of your calculator. If you have a driver's license, if you have a credit card, everybody gets a credit card, right? So you just take any sort of card, put it on there, make it nice and straight. I can't do that on this board, otherwise it won't work, so I'm just going to try my absolute best. Actually, it wasn't that bad. So this line would then have arrows, right, on either side, and it's going forever one way, That yellow line represents this equation. Right? Get a starting point, use the slope to find your other points. Beautiful. Number 2, not quite as easy because that is not slope-intercept form. If we look at that thing and we were trying to figure out what form it is, it's actually in slope point form. So we got y minus y1 equals m x minus x1. To graph, you need a starting point. In this case, the starting point is not a y-intercept. The starting point is just a random point. They give you your random point by using your y1 and x1 values. Remember, the value is actually the opposite of how it looks. So when I'm looking for my starting point, it's not 1, -2, it's -1, (2). It's opposite of how it looks because of the negative symbols in our equation. So my starting point is at x equals -1, I go over 1, y equals +2. That's my starting point. Right in the purple. That's probably the trickiest part of using slope point form, is that your starting point is the opposite symbol of what it looks like in your equation. Fantastic. And again, we're going to use our slope to map out our next spot. The slope is up 2 over 1, right? There's my m value right here. Up 2 over 1, up 2 over 1, over and over and over again. And you create this line, up 2 over 1, up 2 over 1. And again, just connect the dots. Oh, I missed. If you connect the dots, you get a straight line. That represents the equation above. Fantastic. Our last one. Our last one is currently in general form. We can't graph general form. Right? General form doesn't tell us anything. It doesn't tell us what our slope is. Doesn't tell us what our intercept is. Doesn't give us a random point. General form basically gives us nothing. So what we have to do is change that into a form we actually know. The form we're going to change it into is slope-intercept form. We could do that by getting y by itself. To get y by itself, I'm going to add y to both sides. When I add y to both sides, I end up with 2x plus 4 equals y. And I now have slope-intercept form because y is all by itself. My starting point is my y-intercept. This is my y-intercept. It is at +4. My slope, once again, is up 2 over 1, up 2 over 1, up 2 over 1, because that's my slope right there. I'm going to do this quick. I'll try to connect my dots again. Ooh, and this is even worse than the last one. Awesome. If you look at your 3 graphs, what do you notice about them?
They're all the same.
They're all the same. Every one of those equations was actually the exact same equation, just in a different form. This one was in slope by intercept form. This one started in slope point form. This one was general form. When you manipulated them, they actually all turned out to be the exact same. So just a reminder that you can rewrite things in different forms, but it's still the same line. That they all still create this pattern. Fantastic. That's graphing without a calculator. They do have a couple questions down here. We're not going to do them. So this is like matching equations to graphs. If I were you, I would convert all of these into slope point form that are in general form. So like this one right here. Change that to slope form. Intercept form, slope intercept form, and the other two you can just match up easily. And I don't think we need to go through that. I think you guys would be able to graph all those and figure them all out. Awesome. Graphing with technology. We did that in the last unit. Remember that your calculator always graphs using y1 equals. That means the only way your calculator can graph things is if you change the slope intercept form. Okay? So every single equation, if you ever want to graph on your calculator, you need to change the slope intercept form. We did that stuff last unit. That's just kind of more review than anything. What we haven't done a lot of is if we scroll down the next lesson. There we go. Slope is a rate of change. Awesome. So this is going to take word problems and give some context to slope. Okay, so for us, our rise over run has always been rise over run, random numbers, never really any context. You could throw context in there. So here's a question where they've given you a graph with a line, and they've given you two random points. If I said calculate the slope of that equation, and you had two random points, what would your strategy be? Can't really count it because there's no grid here. Two random points means use this formula. Right? y2 minus y1 divided by x2 minus x1. Name one of your points point 1, one of your points point 2. I'm going to say this is point 1, so this is x1, this is y1. This is x2, this is y2. Pardon? They're going really slow. They're going really slow. Maybe not on a bike. Not no. Does it say they're driving? Yeah, it does in the car. Yeah, they're going slow. So if you want to calculate your slope, y2 is 120. Minus y1, so minus 40. Divided by x2, which is 3, minus x1, which is 1. If I put that in my calculator, 120 minus 40 is 80. 3 minus 1 is 2. Calculate that again, that's 40. Awesome. That's how you would calculate the slope of that equation if there's no context given. Right? They just gave you 2 points. You just go y2, y1, x2, x1, calculate. Fantastic. Now, this slope actually does represent something. To help figure out what it is, what I like to do is go to my rise over run, and instead of using the numbers, use whatever your y is divided by whatever your x is. So in our case, I would have kilometers on the top, that's my y values, divided by hours, which is my x. And that gives you context to what your slope actually was. My slope isn't 40, it's 40 kilometers an hour. So we actually were figuring out how fast they were driving the whole time. I think that's the easiest way to do it. Just look at your graph or your context. Your y value goes on the top, your x value goes on the bottom, but now you're just using actual words, and it gives context to what's happening. Kilometers per hour. This line, the slope of it, represents the speed of my car. Awesome. To fill in the blank, I don't know if we have to. The slope represents a change in the amount of fuel in the chain. in the fuel tank divided by the change in distance. Oh, I've gone too far. There we go. I hit down on the wrong key. I was like, what is it talking about? Fuel. We didn't do anything with fuel. The distance is decreasing at a rate of 40 kilometers per hour. There we go. Let's try another one. So the next one is the temperature of an oven. They've given us two random points. If we want to figure out the slope, we can go y2 minus y1, x2 minus x1. So let's calculate that. So slope would be, this is x1, this is y1, x2, y2. That's 350 minus 50 divided by 5 minus 0. That's 300 divided by 50. It's 60. 60 is way too big. Just 6. That screws up. Oh, there we go. Thank you. It is 60. It was 5, not 50. Well, there's something that's really off here. Okay, that's just calculating slope, like back to the basics using your formula. Now, if I wanted to be like, okay, what's that slope represent? What you need to do is try to put context into it. Rise is your y value. So we're talking about the temperature of your oven in degrees Fahrenheit. So degrees Fahrenheit divided by minutes. My slope of 60 represents how many degrees Fahrenheit I increase every minute. That's what it represents. Okay? Degrees Fahrenheit for every minute changed. It makes sense, right? Your temperature is going to go up as the oven heats up. Kind of makes sense. If we looked at this and said, complete the following statement, the temperature it's increasing at a rate of 60 degrees Fahrenheit per minute. That's this right here. 60 degrees Fahrenheit every minute. Cool. Last one. I think this is our last warm-up one. Yeah. So we got this guy here. They're talking about the amount of fuel in your tank and then how far you're driving. So if you wanted to calculate your slope of this thing, then we're doing x2, y2, or x1, y1 right here. x2, y2 right here. We go to calculate that. Y2 is 40 minus y1 is 50. Divided by x2 is 120 minus x1 is 20. That means my slope on the top is negative 10 divided by 100. If you change that into a decimal, it's negative 0.1. So it doesn't calculate into a nice number, but it is a decimal that terminates. So I'm okay with leaving it like that. Especially for these rate of change questions, it helps a bit. If we wanted to put that slope into context now, right? So I've got a slope of negative 0.1. What does that represent? That represents the liters of fuel. So I'm going to put fuel. Per kilometer divided by kilometer. Because it's decreasing, right? I have a negative slope. That means I'm losing 0.1 liters of fuel for every kilometer I drive. That's what that represents. You could also look at back here and be like, I'm losing 10 liters of fuel for every 100 kilometers I drive. And you could even use your fraction to help you put context into something. It's not that hard, I don't think. As long as you just remember to go y over x, kind of follows suit like that every time. We're just going to do d. So it says determine the equation of the line in the form n equals md plus b. So we're used to seeing it like this. Y equals mx plus b. That's the same thing. Except because it's a word problem and there's context to it, their y wasn't y, their y was n. And their x wasn't x, their x was d. But it really is still the same thing. So if I wanted to create an equation for that graph, and I wanted to use slope-intercept form, I know what my slope is. It's negative 0.1. I don't know what my y-intercept is. Right? Looking at this thing, no way of finding my y-intercept. I could maybe try to backtrack and try to figure it out. That's going to be kind of a pain. So instead what I'm going to do is create what the question's giving me enough info to create. I'm going to create slope and then a random point. And then I'll change it to be what they want me to be. So we're going to create an equation in this form. Y minus y1 equals m x minus x1. Even though they wanted slope-intercept form, I'm going to create slope point form because that's what I have the info to create. When I plug in my values, y will stay as y. y1 will change to be, I believe it was 50. If that first point was 20, 50, I can't see my graph. Equals negative 0.1 was my slope. And then we had x minus x1, which I believe was 20. This equation represents that line up above. Now I want to change it to be slope-intercept form because that's what they asked for. Slope-intercept form has y by itself. Our first thing we always do is expand that. So we're going to multiply that into the brackets. That gives me y minus 50 equals negative 0.1 x plus 2. So negative 0.1 times 20 equals 2. The last thing I'm going to do to get it into the proper form is I'm going to get y by itself by adding 50 to both sides. I now have an equation of y equals negative 0.1x plus 52. Because this is a word problem, that equation actually represents things. My slope represents how fast I'm losing fuel, right? We already talked about that. That's 0.1 liters of fuel per minute that I'm losing. What does my b value represent? We know it's our y-intercept, right? Well, what does it represent in the context of this question? If I say my y-intercept is here, and it's at 52, what does that actually tell me? That's the starting liters. Yeah, that's the starting amount I had of fuel. So for word problems, your b value tells you your starting point. I started with, went too far. I started with 52 liters of fuel. and I'm losing it at 0.1 liters per minute. Fantastic. I think we'll probably just do one more. We'll do two. We'll do one. Might as well. So, we got Tyrone working a job. Tyrone is paid base salary per week plus commission for selling electrical appliances. Last week his sales totaled $3,500 and he earned $620 from that. This week he earned $680 for sales of $4,250. On a grid, plot the order pairs to represent this information. So, we've got two pieces of information given to us. We've got his sales and then what he earned. And we've got it in two pairs. The first one was he sold $3,500, he earned $620. So if I'm looking over here, I'm going to say sales, $3,500, earned $620. Put it right there. That is $3,500, $620. That's the first point they gave me. The second point they gave me was they said this week he earned $680, he sold $4,250. So if I'm looking to plot that, sales is bigger, earning is bigger, my point will be somewhere up here. Doesn't have to be the scale. That point would be 4,250. Comma 680. Those are the 2 points they gave me. Question B says calculate the slope of the line segment joining the ordered pairs. So, if I wanted to figure out slope, and all I have is two ordered pairs, I'm going to use my formula y2 minus y1 divided by x2 minus x1. You need to remember that. If I have two ordered pairs, that's the formula I go to. We'll call this one x1, y1. We'll call this one x2, y2. Awesome. Across the top, 680 minus 620 divided by 4,000. I'm just getting my backwards on x2s. 4,250 minus 3,500. Again, when you're calculating these slopes, do the top separate, do the bottom separate. Right? So 680 minus 620 is 60. On the bottom, 4,250 minus 3,750 is 750. And then we would reduce that, right? And I have a hard time reducing that one. That one's kind of tricky. 2.5? 2 over 25. Okay. So this thing reduces to be 2 over 25. If we wanted to give that slope context, we then put units with it. Right? Rise is y divided by x. So rise over run, that means earnings divided by sales. This means he earns $2 for every $25 worth of sales. That's what that represents. So if he sells $100, then you would be able to figure out what his earnings would be. Yeah. We just did part C, so we explained what the slope represented. State as a percent. So if you ever go out there in the world and you start doing like any sort of job that gets paid percentages, sales a lot of the time gets paid percentages, like selling cars and stuff like that. They'll tell you your commission percentage. They'll be like, this is how much you make per sale. Right? For our guy, to figure out the percentage, we turn this into a decimal. So you're going to go 2 divided by 25, which is going to be 0.08. And then you're going to change that into a percentage by timesing by 100. And you get that Tyrone is making 8% commission. That's what that would represent. 8% commission is actually pretty good, I think. Yes, depends what you're selling. It could be really bad. Awesome. E, calculate his weekly base salary. I don't think we're going to have to do that. We might have to. Yeah, we'll do it just for fun. If you were to try to figure out his base salary, because it told us in the question that he gets paid a salary plus commission, right? So no matter what, if he sold nothing, he would get some sort of money back to him. Right? If you wanted to figure that out, that's your starting point. Starting point is your Y-Intercept. Right? That's a fancy way of them asking, what's the Y-Intercept? What's his starting salary? See how they can like twist that a little bit, right? And you would be looking at that question like, I have no idea what the starting salary was. Starting salary is your Y-Intercept. To figure that out, you're going to have to create an equation, create slope point form, because all you have is a slope and a point. Use whatever points you want. I'm going to use 3500, 620. So that means I'm going to have y minus 620 equals m, which is 0.08, times x minus 3,500. If I wanted to figure out his starting point, I'm going to convert this into slope-intercept form. So I take that and multiply it in. That gives me y minus 620 equals, I'm going to have to do 8% of 3,500. It's 0.08x minus 280. My last step would be to add 620 to both sides. I'm running out of space, but add 620 to both sides. And you get an equation of y equals 0.08x plus 340. Thank you. This equation would represent how much money he makes based on how much he sells. Where 0.08 is that how much extra he gets, right? That's his rate of increase as commission. And 340 represents his base salary. That's my starting point. That's my salary. Fantastic. I think we've done enough of these. We're feeling decent with them. Yeah. Okay. There is one more here if you want to do. I guess I should just do H. I didn't realize there's 2 more questions. So we've already written the form and we've already done G. If we look at H, it says 2 weeks ago Tyrone earned $486. Calculate his sales for the week. So they told you what he earned. What he earned was your Y value. So if you go to his equation, you could change y to be 486. Everything else stays the same. 0.08x, 340. And that's kind of like last unit. They gave you a Y value, they're asking you for an X value. They're saying, how much did he sell that week? Sales was X. Saying he earned 486. Earned was our Y value. You then have to try to get X by itself. So we subtract 340 from both sides. This is kind of like, this is last unit. When you do that, you end up with 146 equals 0.08x. To get x by itself, we divide both sides by 0.08. And that'll tell you what his sales were for the week. Should be a decently big number. Anybody calculated? 1,800. Right on the dot. Oh, thank you. He sold $1,825 worth of whatever he's selling. The week that he earned $486. On the back of your assignment, the very last page, I think you have two questions that are kind of around that stuff. No graphing involved, but the info's there.